Okay, so today what we are going to do is we are going to be solving equations and solving different types of equations. So for the title on our notes today, let's just put solving equations. Because we're solving multiple types, and today is the 27th. And this is not correlating with a specific lesson worksheet. So that's why I'm not going to put like number 10 something, okay? Just to clarify. So the first thing we're going to do is we're going to talk about equations that have different types of solutions. So here is first example. 5x plus 10 is equal to 6x minus 20. So I'm not sure if anybody remembers back to course 3, the criteria for understanding what or how many solutions we should be seeing here. So if we're not sure when we look at this, then what we need to do is go ahead and go about solving. And in order to solve, remember, we're trying to isolate the variable onto one side. And in order to do that, we're going to use inverse operations. So with that being said, I'm going to go ahead and I am going to, let's say, take my 6x and move it over here so all my x's are on one side. So inverse, that means that I have a negative x plus 10 is equal to a negative 20. Now I'm trying to get this isolated. So I'm going to move the 10. I end up with negative x is equal to negative 30. This is not a final answer here. And the reason for that is because my x is not isolated because it has this negative out in front of it, which has the invisible coefficient of 1. So because it's not a positive 1, I'm not done with this problem. I need to divide by a negative 1, divide by a negative 1. That means that I have x is equal to 30. Box my answer. There you go. Now, what I'm going to do is I'm going to come back and I am going to do a check. We always want to check all of our equations to make sure that we're solving them correctly. So essentially, I know that my x is equal to 30, and I'm going to rewrite my original problem. 5x plus 10 is equal to 6x minus 20. From here, I'm going to substitute in my value for x. When I substitute into parentheses. So I know that I substituted and I can keep the equation true. So these are touching now. These are touching, which means multiply. This ends up being 150 plus 10, and this ends up being 180 minus 20. Please notice I am not moving things from side to side at this point, right? I'm working through each side by itself. This now makes 160, and this makes 160. Those are matchies, so I know I'm right. Okay, so how many solutions did this have? The answer would be 1, everybody. So this is a 1 solution. And I know that because I have one variable on each side. I have different coefficients and different constants. That would be the criteria for a 1 solution. Okay, then I come down here and I have 6x plus 3 is equal to 6x plus 18. Let me move my camera for you. Woo, making myself sick. Okay, here we go. So first thing I do when looking at this equation is I'm going to look into my parentheses and I'm going to determine if I can simplify. When I look inside, I don't have anything that's alike, so I can't simplify. So my next step would be to go about distributing. When I distribute, this becomes 6x plus 18, which is equal to 6x plus 18. What do I know at this point? Who can come off of mute and tell me? Just come off of mute and tell me.
Infinitely many solutions.
Excellent. Infinitely many solutions. So this is infinitely many solutions. And the reason why is I have the same variable on both sides, I have the same coefficient, and I have the same constant. So infinitely many solutions. Now, anytime I have an infinitely many solution equation, I don't need to check my answer because any number is going to work. Like, that's silly to do and it's a waste of time and it doesn't prove anything. So when you find this pattern, we just know infinitely many and then I'm good to go. Okay, so now we're going to look at one more pattern, which kind of gives away what we're looking at, but that's okay. 6x plus 7 is equal, oh no, oops, sorry. 6x plus 7 plus 3x is equal to 9x.
And we can see it.
Yep, there we go. Thanks for telling me because I'm looking at my own paper, which I can obviously see. Right? So, okay, here we have this here. When I look at this, I am going to start by simplifying the left side by combining like terms. I have a 6x and a 3x. That's going to give me 9x plus 7, which is equal to 9x. What is this pattern showing now?
No solution.
There are no solutions.
Excellent. There are no solutions. And remember, there are no solutions because I have the same variable, same coefficient, different constants. Okay, so that's going to give me a no solution. And when we see a no solution, we're writing no solution. You're not demonstrating this with like anything else. Sometimes kids like to write a 0 with like a slashy through it. That means something else in math. And so we're not going to use that. We need to write out the words. Does everybody understand that? I see a lot of head nods. So I'll go with yes. And then we also do not check a no solution because at this point in time, I can already tell it's not going to work out mathematically. Okay, so the only time we are doing a check when solving our equation is to verify that a one solution answer is correct, and I'm mathematically making sure of that. Now, we are going to look at this problem. 5x minus 2/3 is equal to 11. So my question here is, what is our first instinct onto how to solve this problem? What is the first thing when I look at this I think I should probably do?
You would want to isolate the variable?
Right, I'm trying to isolate the variable. And so based on what we just did a minute ago, my first step would probably be to move this 2/3. Okay, so let's do that. I'm going to add 2/3 and I'm going to add 2/3. That means that I'm left with 5x is equal to 11 2/3. Okay, what should I maybe do now?
Convert 11 2/3 to an improper fraction.
Great.
So it'd be easier to divide.
Absolutely. So I have 5 x is equal to 3 times 11 is a 33 plus 2. 35 thirds.
Yeah.
Okay. And then 5 and x are being multiplied. So the inverse of this would be to divide, which is the same thing though as multiplying by a fifth. Are we in agreement to that? Okay, the reason I multiplied by a fifth is because I have this fraction over here. So if I just say divide by 5, that may not mathematically make sense on the paper. It makes sense being that it's going to be a complex fraction, but you may not be able to understand what the next step would be. So from there, this leaves me with x, and here I can go ahead and do 35 times 1, which made 35, and 3 times 5, which makes 15. Or I know that I can cross simplify these, yes? Okay, and so my final answer should be something like what? 7 thirds?
Yeah.
And there you have it. Now I'm leaving it as 7 thirds because if I was to go back into this problem, I am going to need it to be an improper fraction in order to check it. So let's say I'm going to do my check over here, and I have 5x minus 2 thirds equals 11. I have 5 times 7 thirds minus 2 thirds equals 11. 35 thirds minus 2 thirds equals 11. This works out to be 33 thirds equals 11. So 11 is equal to 11. Great. Okay, now we're going to solve this problem a second way. Because what happens is a lot of my students think we can only solve problems one way, and that's by moving the constant first. But that's not true. So what is a different way we could start this problem off?
You can divide the entire problem by 5.
I could, but
3, maybe.
I'm probably not going to want to divide by 5. There's a fraction here, so most likely what I want is to
Multiply.
try to get that denominator gone. Yes, multiply. What am I going to multiply by?
3.
3.
Okay, so I just multiply this by 3 and this by 3.
And minus
both
2.
sides.
Both sides, everything.
Okay, so I have to take the 5x minus 2 thirds, and I'm multiplying this whole thing by 3. And then I have my 11, and I'm multiplying that by 3. Because whatever I do to one side, I have to do to the other side. I have to keep it even. And whatever I do to one term, I have to do to all the terms on this side in order to make it even. Is everyone following that? So from here, this works out to be what? How would I rewrite this problem now?
You would write it as 15x
Equals 33.
Minus 2
minus 2, yes.
equals 33. Okay? And then from here, now I'm going to move this constant over in order to try to get my x by itself. So plus 2, 15x is equal to 35. Divide by 15, divide by 15. X equals 35 15ths. this is both divisible by a 5. So I'm dividing by 5/5, so my x is really going to be 7/3. And then if I look above, I can see that that's correct. So remember, if I'm going to multiply one term in order to keep the values true, I have to multiply everything in this expression by the same thing. Otherwise, it changes the value. Okay? Okay, I got one more for us to look at. I'm going to squeeze it in on here. So I have m minus 5 minus 3m is equal to 7m plus 10. Okay, so first thing I'm going to need to do, look into my parentheses here. Can I simplify? No, there are no like terms. Next thing I need to do, I need to take this negative and distribute it. So I have m minus 5 plus 3m is equal to 7m plus 10. Now I'm combining like terms on this side. So I have a 3m and another m, which gives me 4m minus 5 is equal to 7m plus 10. I need to get all my m's on one side because I'm trying to isolate that variable. So minus 4m minus 4m. I have a negative 5 is equal to 3m plus 10. Again, trying to get m by itself. Minus 10 minus 10. Negative 15 is equal to 3m. Now I need to do the inverse. These are touching, so I'm going to divide by 3, divide by 3. That's going to leave me with m is equal to negative 5. Box it, and then you should be doing a check because there's only one solution. So there you have it. That is solving equations in a nutshell. Pretty straightforward.